Hi, hello everyone. Welcome back to our channel RL Lab. So, in the last video, we were discussing about the real numbers and we have completed 1.1, 1.2, 1.3 exercises, right? So, today we will try to see about the exercise 1.4. Before proceeding with the sums of exercise 1.4, we will try to discuss about a theorem, small theorem. Let us see what is that means. Theorem is nothing but let P be a prime number, P be a prime number and A is a positive integer, if P divides A, if P divides A square, then it is also divides, then P divides A also. This is a statement of the theorem. If P be a prime number and A is a positive integer, if P divides A square, then P is also divides A. P is also divides A. Just you try to remember. I'll discuss with respect to an example. Here, suppose you take up any number. Let us say I am taking A is a positive, A is equal to 12 I am taking, that is a positive integer, right? Now, P be a prime number, okay? P be a prime number. P be a prime number means, let us say P is equal to some 3. P is equal to some 3. Okay? Then, if P divides, this is a symbol divisibility, right? This meaning is 3 divides 12. If 3 divides 12, then it also should divide 2 square. Sorry. If P divides 12 square, then it also should divide 12. You check out 12 square means, let us say this is 144. If P divides 144, means 144 is the perfect square of 12, right? If P divides 144, 3 4 is 12, 3 is 24. So 144 is divisible by 3. Or else 3 divides P square. This meaning is 3 divides 144 or 3 divides 12 square. This is divisibility. It's not division symbol. It's a divisibility symbol, right? 3 divides 12 square. As per the problem, if 3 divides, here this is 3, this is 144. If 3 divides, this is 12 square. 3 divides 12, then 3 is also divides A. Let us say 12 square means here 12 is there, right? So 3 should also divide 12. Will 3 divide 12? Yes. The factor of 12 are 3 and 4, right? The factors of 12 are 3 and 4. So definitely, as a factor 3 is there in this, definitely divides with the 3. Isn't it? So, from this you take up like this any number. Suppose you take up 2. 2 divides some 36. Means which is equal to 6 square, no? 36 is nothing but 6 square. Then it also should divide 6. It's a square root. Is it true or false? It's true. 2 divides 6 and 2 is also divides 36 also. Like this you take up any prime number and any perfect square. A square is nothing but a perfect square. You take up any perfect square which divides a prime number which divides a perfect square, then it also divides its square root. Clear? So this is what the theorem, right? With respect to an example I have discussed here. So in general also we can write with respect to the variables. Okay, taking A is a prime factorization and B like that already we can do it. That is easy. Just keep in mind that if a prime number divides a perfect square, then the prime number is also divides its square root. Then the prime number is also divides its square root. Clear? Please keep this in mind. Just a minute. Exercise 1.4. First problem. Prove that 1 by root 2 is irrational. Okay. So, in general, in order to prove any problem, we will have two methods. One is direct method and another one is indirect method. In the direct method, what is given in the direct method, the procedure is we will take the given statement and we will obtain the conclusion. But in the indirect method of proof, what we will do means we will take the contrary to the given statement. Controversy. Contrary means the given, we will take the given statement is wrong. We will take that the given statement is wrong and we will proceed with the few steps. After few steps, we will come to know that our assumption is wrong because we have taken the given statement is wrong. That is why our assumption has become wrong. So what is right means the given statement itself is right. This is the way to find the indirect method of proof. And in the direct method of proof, we will take the given statement if part and we will prove the then part. So in this 1.4 exercises, all sums we will try to discuss in the method of indirect proof. Indirect method of proof. Okay. So now in this proof, first what I will do is I will assume let 1 by root 2 be 1 by root 2 be a rational number. 1 by root 2 be a rational. Once it is a rational, it should be in the form of, rational number should be in the form of P by Q. Rational number should be in the form of, that implies 1 by root 2 is equal to P by Q. 1 by root 2 is equal to P by Q. Where P comma Q are integers and Q is non-zero. At the same time, here what we have to assume means P and Q are also should be co-primes and co-primes. Okay. Now you do the cross multiplication. Q is equal to P root 2. Now you bring this side P. Q by P is equal to root 2. Right? So clearly Q by P is equal to root 2. Now in this, what we have assumed here, this is enough because I will show how to prove this root 2, root 3, root 5. Root of non-perfect square numbers is irrational. I will try to prove in the coming problems, right? So Q by P is equal to root 2. Generally, square root of perfect squares only gives us to the integer. Square root of all non-perfect squares gives us to the irrational number. Okay. So here, I'll write here, what is this solution? Since what are P and Q are? P and Q are? Since P and Q are integers and co-primes, since these two are integers and co-primes, then Q by P becomes integer by integer, no? Integer by integer become a rational number or not? That implies Q by P is a rational number, isn't it? It is a rational number. Once it is a rational number, Q by P is a rational number, that implies it's RHS. Q by P rational number is root 2 is also should be rational number, no? Root 2 is also a rational number. Root 2 is also a rational. But is it correct? Is root 2 is rational? No. It's an irrational number. Why? Because square root of non-perfect squares are irrational. So, but this is contradicts the fact that, contradicts the fact that root 2 is irrational. Okay. Root 2 is irrational. Why this contradiction has arisen? Because of our wrong assumption. Clear? This has arisen. This has arisen because of our assumption. Because of our assumption 1 by root 2 is a rational. So what is right? 1 by root 2 is not a rational number is our conclusion. Therefore we conclude that therefore we can conclude that one by root 2 is irrational. Clear? In this method of proof, we have taken the given statement is wrong, that is not irrational. We have taken that is a rational number. Once any number is in the rational number, that should be in the form of p by q. So where p comma q are integers and q must be non-zero, this is a rational number condition, and we are taking that they should be co-primes. Okay. Now by cross multiplication, we get here by cross multiplication. By cross multiplication, we get q is equal to p root 2, and p you bring this side, so that q by p is equal to root 2, or else root 2 is equal to q by p. So since p and q are integers, q by p is what? Integer by integer becomes a rational number. Once LHS is rational, then RHS also should be rational. No? The root 2 is also a rational number. Clear? Q by p is a rational. Since these are rationals, then root 2 should be rational. So, but this contradicts the fact that, what is the fact? Root 2 is irrational. Because under the square root, 2 is a non-perfect square. So, the square root is irrational. Why it has arisen? Because of our assumption 1 by root 2 is a rational. So, then what is right? Our assumption is wrong. Here our assumption is wrong. No, this has arisen because our assumption 1 by root 2 is a rational. So what we can conclude? 1 by root 2 is irrational. Or else here one more statement also you can include, that therefore our assumption is wrong. Therefore our assumption is wrong also you can include here. So why I have written this much space is there, I can write here also. But these are the steps. These are the steps. Step 1, right? Step 2, step 3, step 4, 5, 6. These are the 6 steps which we need to follow, which we need to write same for remaining all sums of 1.4 exercises. The change occurs only in these fractions. The change occurs only in these fractions. And this root 2, this q by p, and this only change occurs in this remaining part is as it is. Clear? So let us see next problem. Root 3 plus root 5. Before going to the root 3 plus root 5, I'll try to discuss third and fifth is same. I'll try to discuss fifth problem. You can do third problem easily. Then after I'll come to second problem. Then after I'll go with the fourth problem. Okay? Right. Now, what is there means? Let us try to discuss about this clearly, so that you will not get any confusion. But these are the steps which we need to remember, right? This I am erasing here. For every problem they will not be same. Okay. So that is why I am erasing. So the next fourth, what is the problem number? Fifth. Problem number 5. 3 plus 2 root 2. 3 plus 2 root 5. 3 plus 2 root 5. Clear? 3 plus 2 root 5. Prove that 3 plus 2 root 5 is irrational. Simple, same procedure, no change at all, I am telling you. Definitely same procedure. Let us assume that 3 plus 2 root 5 is a rational number. Is a rational. Once it is a rational, as far as rational number definition is concerned, it should be in the form of p by q. It should be in the form of p by q. What is p and q? P and q are, p and q belongs to, z, and q must be non-zero. Not only this, they must be co-primes. They must be co-primes. Clear? Now, so in all these cases, you need to make irrational number. The square root of the particular number will be there, no? That number you need to make as a subject. So in order to, in this process, what are the remaining elements will be there that you try to send to the other side. Okay, here in the LHS side 3 is what doing, 3 operation is 3 plus. So if you send this 3 to the RHS, that becomes minus. So left over 2 root 5 is equal to P by Q minus 3. Clear? Now 2 root 5 is equal to, here you do the LCM, LCM is Q, here you will get P minus 3Q. Now you have to get only root 5 but not 2 also. Send this 2 to the RHS. What is the operation is doing here? 2 operation is multiplying. 2 on root 5 operation is multiplying. So send this 2 to the RHS. If you send, that becomes division. Isn't it? Because in the LHS 2 is multiplying. If you send to the RHS, that becomes divide. So we have made a subject of root 5, right? So root 5 is equal to P minus 3Q by 2Q. P minus 3Q by 2Q. So an irrational number is equal to P minus 3Q by 2Q. Next step is immediately you can write this. Since P and Q are integers. Since P and Q are integers. So P minus 3Q is a rational number, isn't it? So P and Q are any numbers. Let us say 3 and 4. Let us assume 3 minus 3 into 4. Some minus value you will get. Let us say minus 4. Next by 2k. 2 into 3. 4. Minus 4 by 3. Is it a integer or not? Minus 4 by 3 is a rational number or not? 4 numerator and denominator are integers, and both numerator by denominator becomes a rational number. P minus 3Q by 2Q becomes a rational number. Once it is a rational number, then this part, once RHS is a rational number, LHS also should be rational number. So root 5 is also rational number. Root 5 is also a rational number. But this contradicts the fact that square root of non-perfect square is irrational. Square root of non-perfect square is irrational. This has arisen because of our assumption 3 plus 2 root 5 is rational. Because of our assumption 3 plus 2 root 5 is rational. So what is correct then? Here we can add one step here. Here we can add one step. That step is, therefore our assumption is wrong. Therefore our assumption is wrong. What is wrong? Our assumption is wrong. Therefore what is right? Therefore 3 plus 2 root 5 is irrational. Therefore 3 plus 2 root 5 is irrational. Hence it is proved. Hence proved. Clear? I hope this is understood by everybody. It's very simple. In this method, in this fourth exercise, definitely you will get a 4 marks question or 6 marks questions. Okay. So it's very simple. In which year? I think 2017. I think so. Only same problem. This problem only is given as essay question. Prove that 3 plus 2 root 5 is irrational. It's very simple. Simple steps. And these are the part we have to make. See, for whole exercises, this part is same. This part is compulsory for all the problems of 1.4 exercise. For all the problems of 1.4 exercise, this is very important, right? Next, we'll try to discuss about second problem, root 3 plus root 5. So far we have seen only 1 by root 2 and 3 plus 2 root 5. Next 6 plus root 2 is one more problem. Is that two terms are there, but only root is for only one term. Now in this problem, root is for 2 sums. Right. Next, second problem. First bit, second problem. Prove that root 3 plus root 5 is irrational. Okay. So far we have seen a square root for only one number. Now this is 2 terms. For both the terms there is a square root. In this case, how to do it? Please be concentrate. It's very important for essay question. Okay. So let us assume procedure is same. There is no change at all. Let us assume that root 3 plus root 5 is a rational number or be a rational number. Okay. Root 3 plus root 5 be a rational number. Once it is a rational number, it should be in the form of P by Q. Root 3 plus root 5 should be in the form of P by Q, where P comma Q are integers and q must be non-zero, and they should be co-primes. Remember, not only integers, they should be co-primes. Now, anyhow, in our intention is you need to make one of the square root of non-perfect square should be make a subject. In that case, you try to send one of the number to the RHS side. One of the number to the RHS. So I am sending root 5 to the RHS. Root 3 I am keeping here only, and root 5 I am sending to the RHS. Then that becomes minus root 5. In this case, you do squaring on both sides. Squaring on both sides. So whenever you are doing squaring on both sides, this become root 3 whole square, and this become p by q minus root 5 whole square. Clear? Now I think this is in the RHS, this will be gets cancelled in the LHS. 3 is equal to, in the RHS this is in the form of a minus b whole square. What is a minus b whole square formula? A minus b whole square is equal to a square plus b square minus 2 root ab, and a square plus b square minus 2ab. This will be the formula for finding the a minus b whole square, right? Right. Now here this will get cancelled. 3 p by q whole square. Okay. Next b square. B square is root 5 whole square. Next minus 2ab. Minus 2 into p by q into root 5. Clear? Okay. So now what we get here? 3 is equal to p square by q square plus square and root gets cancelled 5, and this is minus 2p root 5 by q. Done. Now in this all the terms in the RHS, there is in the third term there is a root 5. So for root 5 term you have a minus symbol, right? You try to bring this is to the LHS side. You try to bring this is to the LHS side, and you send this 3 to the RHS. So that what will becomes this, if you send this side and this you try to send RHS, that becomes plus 2p by q into root 5 is equal to, now p square by q square plus 5 already it is 8, this plus 3 if you bring it minus 3. Clear? So then what we get here in the LHS side, 2p by q into root 5 is equal to, so what will you get here? If you do the LCM, that becomes q square. Clear? Then here p square plus 5 minus 3 is 2. 2 into q square, 2q square. Just I am doing LHS. Okay. Now 2p by q, this side is multiplying. If you send to the RHS, that will be reverse. It will divide. So if you do cross multiplication for this, p square plus 2q square divided by q square. If you bring this 2 by p this side, that becomes q by 2p. Clear? This q gets cancelled. So root 5 is equal to p square plus 2q square divided by 2p into q, 2pq. Right? You make a note of it this year. Clearly, here I have sent root 3 to the RHS, root 5 to the RHS, right? So that after that I have made a squaring on both sides. LHS is very simple. Square and square root will be gets cancelled, you will get 3. In the RHS, I have applied a minus b whole square. This RHS is in the form of a minus b whole square, which is nothing but a square plus b square minus 2ab. Now a square means p by q whole square, b square means root 5 whole square, minus 2 into a into b. A means p by q, b means root 5. Now p by q whole square is nothing but p square by q square. Root 5 whole square means root and square root gets cancelled 5 minus 2 into p into root 5 by q. Right? Now I am bringing this 2p root 5 by q to the LHS and sending 3 to the RHS. So this will be result you will get. 5 minus 3 is 2. P square by q square plus 2 means you will get, if you do the division, you will get p square plus 2q square by q square, and you take out this 2p by q LHS side because we don't require, we have to make root 5 as a subject. So root 5 is equal to p square plus 2q square by q square into q by 2p. Qp gets cancelled, left over with this. right? P square plus 2p square by 2pq. Since p and q are integers, here what we can write? Since p and q are integers, so what happens? LHS p square plus 2q square by 2pq becomes p square plus 2p square by 2pq becomes is a rational number. That becomes a rational number, isn't it? Yes. Now, so that too you try to mention here. P square plus 2q square divided by 2pq becomes integer by integer becomes a rational number. Once it is a rational number, this is also should be rational number. Root 5 is also a rational number. But this contradicts the fact that root 5 is irrational. This has arisen because of our assumption. What is assumption? Root 3 plus root 5 is a rational. Root 3 plus root 5 is a rational. So our assumption is wrong. Then what is right? Root 3 plus root 5. Root 3 plus root 5 is irrational. This is very important problem. Whenever you find roots for both the terms, so roots for both the given terms, you try to send one of the term. See here I have sent root 5 to the RHS. You can send root 3 also, no problem. Without sending also you can find it. Without sending also you can find. Then without sending, what will be the problem will arise means, once without sending means suppose here root 8, here root 2 is there. In that case, without sending, if you do, you will get a perfect square. Root 8 into root 2, you will get root 16. So in that case, there is a chance to get wrong. So my sincere suggestion to all of you is try to send one of the given terms to the RHS. One of the given term to the RHS, then do the squaring on both sides, then do the simplification. You will get one of the square root of irrational number will be equal to some other number you will get in terms of p and q. And this is the procedure which we need to follow. These are the steps for every problem in this particular exercise you need to write. Clear? So this is about 1.4. I have discussed for problem number 1 by root 2, and this is second problem root 3 plus root 5, and fifth problem 3 plus 2 root 5 also I have discussed it. So I am giving only third problem 6 plus root 2 as a homework. Okay. Next, one more thing. There is a fourth problem root 5 I need to discuss. So if I say root 5, you can able to do root 3 and root 2 also. Okay.